Okay guys, welcome. Today we'll talk about the PWM module, and we drive a servo motor through the PWM module. But before we get in, I want to talk to you about what is the PWM module and how we use that. In my previous lessons I already talked to you. There is no analog signal from outside in an Arduino. You can have it, but you can only have a PWM signal. But what is the PWM signal here? The PWM signal is kind of square wave, just you see on the screen here. This is my own PWM signal that we are going to have from the outside, and we determine the value of our own PWM signal with the duty cycle. But what is exactly the duty cycle? Let me copy it and go to paint. Here we go guys, this is my own 4 different waves that I have here, and these waves have got period. Yeah, this is my one period, and during the period I can choose how much hike I'm going to have. If my 5 voltage is 0 during one period, it is called 0% duty cycle. If during one period I have got 25 of the period as a hike, it is called 25% duty cycle here. If I have got the 50% duty cycle, it means in my one period half of it is going to be hike, and I can choose it as a 75%, or in my one period I might have the 100% duty cycle here. But there are the specific number, specific duty cycle I have. If I want to have my own duty cycle, what I'm going to have? Normally the PWM signal, here we go, we can give the value from 0 to 255 using the function PWM, because it is 8-bit. 2 to 8 is 256. That's why my the value that I'm going to read or write from the PWM is going to be stored in 8-bit. That's why if I have a minimum duty cycle, it is going to be present as a 0. But if I have 100% duty cycle, it is going to be 255. Let's go back to paint here and make a simple map. We already know that 100% duty cycle represent with guys here 255. Yeah, in this case I'm going to choose the specific duty cycle that I am looking for. Let's say 20. To have a 20, what kind of value, what value I need, and this is simple math. From here I'll have as x, and let's calculate it for you guys. X equals to 20 times 255 divided by 100, and then I'm going to have my own value to have the duty cycle 20. Let's make that calculation here. 20 times 255 divided by what was it, 100. Here we go, 51. Yeah, 51. If I put the analog write instructions 51, I'll have 20% duty cycle. What kind of duty cycle you have here? How much of the period has to be high? You can choose specifically with that simple equation here. How we are going to use a duty cycle here? We'll drive a servo motor here, guys, with the PWM signal. As you see, it is connected to pin 6 because it is marked as a PWM pin, PWM module pin. You can also use the 6, the pin 5, pin 3, pin 1, 2, 3. These pins are port B1, port B2, and port B3 can use as a PWM module. This means I'm going to read my own analog value from analog input, just like we did in the previous lessons. and then according to that I'm going to have my own duty cycle. I'm going to choose my own duty cycle. If it is 0, my duty cycle is going to be 0, and I expect my motor, my servo motor, not to turn. But if I got 5 voltage, it means my duty cycle is going to be 100. It means I have 255 positions value in my integer value, and it is going to be turned 190 degree. And when my value increase from 0 in my voltage, analog voltage in the input increase from the 0 to 5 voltage, I expect my the servo motor is going to be turned, and will also simultaneously read the PWM module through the oscilloscope here. Okay, let's go to our own program. What kind of program we have to run that program? This is an easy project that I'm going to add it in the descriptions that you can have if you want to work with that specific code, but you can also adjust code according to your own the project details. The first thing that we have to know that we are going to add the servo motor library here with that specific code, including servo.hash, and then I'm going to have a variable as a my servo, and the data type is going to be servo, just like we learned to data types. There was integer, char, long, whatever we have. For example, we have got here int value, the position value, and the data type is integer. We have got here my servo. This is variable, but the data type is servo specifically because it comes with the servo motor library. Okay, we're going to make our own adjustment in the void setup, and my servo, this is my specific name that I chose, that attached 6. It means my servo attached, connected with the 6. I'm going to read my value from the pin 6. This is like just choose a pin mode, same. And we have here our own void loop. In the void loop, first thing that we are going to do to read the analog value from E0 and put it in the position. The 3 point that I already told you guys, analog signal is going to store in the 10 bits, and 10 bit is start from 0 and goes till 1024, but my position has to be between 0 and 120, 118. That's exactly 80. That's exactly why I have to convert that value to 10 bit to 118, and that's why I've got specific the code here. Just called the map. With the map, I'm going to make that converge and put it in positions either, and I'm going to write my positions to my servo. It means the pin 6, and I will put either delay 15 milliseconds to just read the outside the better. It's going to be more understandable. Let's verify, compile our own program and see does it work or not properly. Okay, done. Compiling is done. Then I'm ready to run on my own project, and let's start the simulation. Yeah, here we go, guys. I've got here 5 voltage. And it equals to 19 degree. But when I move my own pod, as you see, it is turning till minus 90. It means 190 degree. I'm going to move my own servo motor through to my own analog signal in the analog input pins. Another point, my duty cycle. If my duty cycle, guys, is increasing with my own the value, my servo motor is also getting increase. This means, see here my voltage, it is going to increase, and my duty cycle is also getting increase. And when I have a bigger duty cycle here, it means my motor degree is going to be bigger. Yeah, this is how we use a PWM signal with the servo motor. To run the servo motor is really important because it is essential, the motor type, and we always use in the robots, the robot arms and other kind of the the specific project that we have the precious the degree, because as you see we can have the specific degree whatever we want. That's why in the precious the project we always use servo. That's why to know how to run a servo is going to be the virtual for everyone when we do that with the analog signal through the PWM module. And I hope it worked in your own projects. Thanks for watching, guys.